Ladies and gentlemen, let me introduce myself. My name is Bagas Rahmatullah from Brawijaya University as Assistant Researcher of Mr. Yusuf Hendrawan. And now I will be present about AlexNet Convolutional Neural Network to classify the type of Indonesian coffee bean. Have you ever thought if Indonesia has an opportunity in developing the coffee processing industry? Because it has a large market, it is also supported by potential of raw material. Even based on data from World Food and Agricultural Organization or FAO in 2017 until 2018, Indonesia was listed as the fourth largest producer of coffee bean after Brazil, Vietnam, and Colombia. Also, Indonesia's tropical climate provides its advantage in terms of coffee production, such as coffee plant is very suitable to be planted in tropical climate, precisely in the tropical area north and south of the equator. And coffee production in Indonesia is spread across various regions from Sabang City to Merauke City, and then several types of coffee produced by Indonesian farmers are already known in the world. Some of Indonesia-based coffee include Gayo, Kintamani, and Toraja coffee. Gayo coffee comes from Gayo Highland in Aceh and has a watery texture, not too thick with rice sour taste. And Kintamani coffee comes from Bali area. This coffee has a unique taste, that sour and fresh taste of the fruit it is specialty. And Toraja coffee comes from Sulawesi area, has an earthy taste with the sensation of soil or forest taste and allows sour taste. So, based on the potentially coffee bean in Indonesia, we need method to identify the best type of coffee from Indonesia because coffee products are vulnerable to being counterfeited. And one method to detecting agricultural product variety is computer vision. Many studies have proven the effectiveness of computer vision and artificial intelligence in detecting the physical characteristics of agricultural products. Like Hendrawan et al., they have successfully used computer vision to inspect the quality of luwak coffee green bean using an artificial neural network with an accuracy result of the mean square error or MSE validation of 0.0442. And also Javan Mardi et al. That have proven the effectiveness of computer vision combined with convolutional neural network or CNN modeling to classify corn seed variety. The results show that CNN perform better than artificial neural network, support vector machine or SVM, Weikai nearest neighbor, boosted tree, Bayes tree, and linear discriminant analysis. The classification accuracy reached up to 98.1%. This study is aimed to classify three types of Indonesian Arabica coffee bean, such as Gayo Aceh, Kintamani Bali, and Toraja Tongkonan by using convolutional neural network or CNN and computer vision. The tool that used in this research is Scanner Brother and desktop PC with Core i3 Gen 4, and the material is 3 coffee bean type such as Gayo Aceh, Kintamani Bali, and Toraja Tongkonan. From the image acquisition process with Scanner, the image was obtained with a resolution of 1721 pixels in JPEG format. And total 1500 image data with 3 categories were used as training and validation data. And data will be divided 70% for training and 30% for validation. Based on figure, it can be seen that Indonesian coffee bean in each type look almost the same. So it is difficult to distinguish by observation from external appearance. And the blending method was used to model image data in categorizing of type of Indonesian coffee bean. And that is the CNN architecture that used in this research, that we see input data will be through feature extraction and that will be classified to 3 types of coffee bean. In this research, we use some parameters to train CNN model that we can see in the slide, such as optimizer that we use HDM, ADAM, and LMS probe with initial learning rate of 0.0005 and 0.0001, and epoch also mini batch size is 20. And that is the result of sensitivity analysis that modify some parameter like optimizer and learning rate. Based on the obtained result, it showed that AlexNet CNN model produced perfect classification with 100% accuracy. The fastest training process was achieved when using the Adam optimizer and learning rate of 0.00005, which was about 153 minutes. And that is the chart training process of AlexNet Bridge network. From that, we can see all CNN models show an effectiveness training process performance, where the accuracy value increased with increasing iteration. The opposite applied to the loss value, where the loss value decreased with increasing iteration. Based on figure, we can look almost the same pattern where shown by the SIG-based CNN model. The training and validation performance chart pattern appeared to move quickly at the initial epoch and the convert at the next epoch, where the accuracy value moved increasingly converging to 100% and the loss value converged to 0. In terms of stability of the training and validation process, we can see in figure A and D is AlexNet with SGDM optimizer and learning rate of 0.00005 and 0.0001. That is so a fairly stable training and validation process with less fluctuation. If we compare AlexNet with SGDM optimizer that we see in figure E and D with the other optimizer that we can see in figure B, C, E, and F, it can be seen that AlexNet model has a slightly fluctuating, less stable training performance. After the best results were obtained in the training and validation process, we will also testing the performance of the CNN model using the testing set data. With the 100 image on each classification, so the total set data is 300. The SIG-based CNN model, when tested using the testing set data, they all produce the same performance, the same accuracy value, and the same error value. So, conversion metric in the study, one conversion metric result was shown representative of the best SIG CNN model. From the result of the conversion metric, it appeared that average accuracy of the testing set data was 99.6%, where the accuracy value was very high for classifying the type of Indonesian coffee bean. In detail, the type of Indonesian coffee bean of Gayo Aceh and Toraja Tongkonan, the CNN model was able to accurately calculate 100% without the slightest error. While in the type of Kintamani Bali, the CNN model only made error of 1% and was still be able to classify the Kintamani Bali coffee beans with an accuracy of 99%. The conclusion is the combination of the CNN model and the low-cost digital commercial scanner can later be used to detect the type of Indonesian coffee bean with the advantage of being non-destructive, rapid, accurate, low-cost, and real-time. And that is the end of the presentation, and thank you for your attention.